Okay, today we're on Chapter 1, Functions, and this is Section 1.2, Domain and Range. So interval notation is used to indicate the domain and range most of the time. And with this, we use brackets to indicate the endpoints that are included in the domain or range. And that usually comes from the fact that we have greater than or equal to or less than or equal to. And then we have parentheses, just like we have parentheses, indicates the endpoints that are not included in the domain or range. And this is usually when we have just strictly greater than or strictly less than. So what we have is we have different ways to notate the same thing. So we have the inequality notation, x is greater than a, which indicates interval notation is going to be going from a to positive infinity. We can graph it on a number line. So we have a parenthesis because it doesn't include that point all the way up to, positive infinity over here. We could also do an open circle. So open circle and parenthesis are kind of the same thing. And again, I said x is greater than a. Then we have x is less than a, and so it's going to go from the negative infinity up to a, but not include it. And again, this could be an open circle, and then we have x is less than a. Now here we have x is greater than or equal to a, so that means that endpoint's included, and so we'll have a bracket a, comma, positive infinity. And when we have a bracket, the same thing there, we can use a closed circle instead of an open circle. So open circle means that point's not included. Closed circle means that point is included. And then we can just kind of go down and all the same thing. We have less than or equal to a, so we have from negative infinity to a with the bracket. And so it goes, this direction, and then we can have our closed circle here. Here, A is strictly between A and B, so that means it's going to have parentheses on each end. And whatever the A and B are, it's going to be somewhere in between there, but it doesn't include the A and B. Now this one says, it's going to be greater than or equal to A, so it's going to include A, so we have a bracket there, but it's not going to be including B, it's just going to be less than that, so we have a parenthesis there. So in this case, we have the closed circle and an open circle. And here we have a is less than x, so that's going to be an open circle, and that's less than or equal to b, which is going to be a closed circle or parenthesis and bracket. And so again, open circle, closed circle. And then we have a less than or equal to x less than or equal to b, so it's going to include a and b, so we have brackets on both of them, or in this case, we'll have the closed circle on both of them. And again, these are just different ways to indicate where the values lie. So interval notation is going to be a key one, but we also need to know how to do inequality, graphing on a number line, what it actually says, and to also help us solve problems. Now, as we saw in 1.1, the domain is the set of the first coordinates of the ordered pair, basically your x's, which are the inputs. And so this is going to be all of your domains. Then the range is the second set of coordinates, basically, or the y's and the output. And so this is going to be, the second part of the ordered pair. So if they give us a domain of a function in ordered pairs, and a domain is negative 5 comma 4, 0, 0, 5 comma negative 4, 10 comma negative 8, and 15 negative 12, that's our set of ordered pairs. We can, basically come up with the actual domain and range. We could say, okay, well, the domain is all the x's, and so that would be negative 5, 0, 5, 10, and 15, and our range is going to be all the y's, the 4, the 0, the negative 4, the negative 8, and the negative 12. So if we needed to write them out, we could, but if we don't have to. So let's go ahead and do kind of what we said. The domain is basically going to be the set negative 5, 0, 5, 10, and 15. And our range is going to be all the y's. And so it's going to be 4, 0, negative 4, negative 8, and negative 12, okay? And so that would be our domain and our range. Now, if we're given a function in equation form, we can still find the domain. What we have to do is we have to first look and identify the input values. So basically, usually it's the x values we input. And then we identify any restrictions on that input and exclude those values from the domain. And then we write the domain in interval form. So trying to figure out what items we have to exclude, that's going to be really the key part of finding our domain. Now, if the equation includes a fraction or some kind of a root, basically we're going to set the denominator, if it's a fraction, equal to 0 and solve for x. And if the function formula contains an even root, we're going to set the radicand greater than or equal to 0 and solve. And then those are going to be the values that it cannot be. And so if we find a value for x when we set the denominator equal to 0, say of 3, that means x cannot equal 3, or you're going to get 0, and so that's going to be a value we exclude. And maybe in the radicand we find it has to be all values greater than 2 or something, and so then we're going to exclude everything else, and then so it's going to be everything to the left. It's going to be everything less than 2. And then we're going to write our domain in interval form, being sure to exclude those restricted values from the domain. And for an even root, exclude any real numbers that result in a negative number in the radicand is what we're doing. So we don't want to have an imaginary number in our radicand. That's why we're setting it greater than to the 0. All right, so what we want to do is here it says find the domain, and so they give us, I don't know, we're going to have, I don't know, 4 or 5 we have to look at here, and we want to see what is our input. Well, we're inputting x, okay? So if we put x in here, are there going to be any restrictions on x's that we can do here? Well, we can plug in any positive x is fine, we can plug in any negative x is fine, and all of them are just going to be squared, so it doesn't matter really here what values we plug in for x, and so there's going to be nothing excluded because anything can be squared. And so what does that mean for our domain? Well, our domain is going to be basically, if we write it in interval notation, from negative infinity to positive infinity, because everything can work. We can plug in negative 5 million here and it'll work. We can plug in 233 and it'll work. Okay. Now what about the second one? Well, again, here our x is going to be the input value, and x is under the square root. So that means what we have to do is we have to set what's under the square root, our radicand, 6 minus 2x, greater than or equal to 0, and then we have to solve for x. So what I'm going to do is I'm going to take that 2x to the other side. And that way I don't have to divide by a negative, because if you divide by a negative, you have to always remember to switch your inequality symbol, and sometimes people forget to do that. So if I take it over here and divide by a positive, we're fine. So 6 is greater than or equal to 2x. So if I divide by 2, then I have 3 is greater than or equal to x. Now this is another problem a lot of people have. They say, well, it's going to be greater than. So they just draw it wrong. And really what we have to do is we have to start with the variable here, which is x, and read that direction. And it says x is less than or equal to 3. And so it's always best, I think, in rewriting it as the variable on the left, and then you can understand what it says. And so if we draw that graphically, because sometimes these are easier to draw and then write the inequality from. So here's our 3, and it's less than or equal to, so we have a solid circle or a bracket and everything that direction. And so we're going basically from negative infinity up to 3, and we include that 3. And so that is basically going to be our domain. Everything that's above 3 is going to make this a negative, and we don't want that. And so that's going to be out of our domain. And so our domain is just in this region here. All right, so this one we have a fraction. So remember what we do with fractions. We set the denominator, 4x plus 2 equal to 0. Okay, well, when you do that, we subtract 2, we get 4x equals negative 2. Now we solve for x, so we divide by 4. So x is equal to a negative 1/2. Okay. Now, remember, what we do is we want to exclude this value. So we don't want x to be negative 1/2. So exclude x equals negative 1/2. And so if we look on a number line, that's going to be the part we need to look at. Here, let's call that negative 1/2. And so we can have everything less than that, and we can have everything greater than that, but we can't have that value. And so how do we write that? Well, we write on an interval notation for a domain. We're going to go from negative infinity up to a negative 1/2, and now we have a parenthesis, and then we're going to go union, and then we're going to start at the negative 1/2, and we're going to go all the way up to positive infinity. And so this would be our domain for this function, because again, we do not want 0 in the denominator, and if we plug in a -1/2 here, we get 0, and so therefore we have to exclude it, and this is how we're going to exclude that 0. All right, so this one's same thing. We set that denominator, x squared plus 9x minus 22 equal to 0, and we solve for x. Well, how do we solve something like this for x? Well, we can use factoring is the most logical way if it's easily factored. If not, then there's the other methods we can do. But this one, I think I see a method we could do for this one for factoring. So what factors of 22 are subtract and give us 9? Well, 22 is basically 2 times 11, and 11 minus 2 is 9. So if I take x plus 11 and x minus 2, those are going to be the factors here. And so what I need to do now is set each one of those equal to 0. And so x is equal to -11 and x is equal to 2. And these are the points we have to exclude. So exclude that and that. And so on a number line, and again, I always go back to the number line because that's sometimes the easiest way to do it. And so here, this is our -11. Here, this is our 2. And so it cannot equal those. So, those are points that it's not able to equal. But it can equal everything to the left, and it can equal everything in between, and it can equal everything greater than. So since it can't equal that, we're going to say, well, that's going to be open circle. And this would be what our number line looks like. And so we just start from the left and have our domain start from the left. That's -infinity. And remember, with infinity, it's always a parenthesis. And then it comes up to -11. Now we've got a parenthesis again, union. Now we have to start there also, -11. And now we go up to 2. Now we have to skip it, and we go union 2. Now we go up to positive infinity. So that then would be our domain. So sometimes they can get complicated with 3 pieces. Sometimes you might end up with more, but that's how we're going to solve these. We're going to set, in these cases, set the denominator equal to 0, and then whatever it is, we exclude those. When we have a radicand, we set that greater than or equal to 0, and then we work from there. And then when it's just a number that can work, we just say nothing's excluded, and it just goes from -infinity to positive infinity. All right, so we can also use a couple other types of notation. So we can also use set builder notation instead of interval notation, depending on the problem and what it asks for. And the form of set builder notation is basically x, and then we have this here line, and it means such that, and then some statement about x. So whatever the statement is. And so it says the set of all x such that the statement about x is true, okay? And so what we're going to do here is we're going to look at this number line. And again, like I said, number lines are a good way to start to write out everything and then go from there. And so what is this number line saying? Well, it's saying we're going to go from -infinity up to 2, and then that's a close, so it's bracket. Then we're going to union, we'll have another bracket, and it's from -1, and did I write the negative here? I don't think so, but it was supposed to be there. And then from -1 up to 3, but it's going to be a parenthesis because we have an open circle, okay? Now, when I wrote it this way, basically what that is that is our interval notation. So this is what we would normally start with, is what usually I would do. But now we also have to think about what is an inequality form of that. Well, here, now we kind of have to start and say, okay, well, this is the whole part here. So x here is going to be what? Well, it's going to be less than or equal to the -2. And then this one has to be between two things. And so something -1 and 3, and x is going to be between them. Now, because this is an open circle, that's strictly less than. Now, because this is a closed circle, it's going to be greater than or equal to. Okay, so now we've got 2 pieces. Now with inequalities, what we do is we say x is less than or equal to -2, or -1 less than or equal to x less than 3. And so we put that or in there. Now with set builder notation, all we do is we say, well, we've got the set of all x such that, and then we write our inequality part here. So x is less than or equal to -2, or -1 less than or equal to x less than 3, and then end set. Okay, and so that's the 3 different ways we can write what this graphical representation shows, and that would be how we would do this one. All right, we can also find domains and ranges from graphs. So what we want to always do is we want to write from the smaller values to the larger values. And if you think about what I've been doing on the number line, I'm going from the left to the right, so smaller to larger. And so it's going to be left to right on the graph for the domain, because remember, the domain is our x values, so it's going to go from left to right. But if you think about the range is the y values, and the smaller ones are down here, the larger ones are up here. So we're going to go from the bottom to the top for the range. So what we want to do is we want to find the domain and the range for each of these. Okay. Well, the domain. Well, the domain starts here, and it's a -4, and it's a closed circle. So we're going to have from -4, and then it goes all the way here up to +4. And again, it's a closed circle, so it would be another bracket. Now, where does our range go? Well, if we come up here, the first time we hit anything is at basically the y equals 0, and it is included because we have the closed circle. So it's going to go from 0, and it goes all the way up here, and this is a continuous line, so it goes up to 2, and again, it's a closed one, and so we have the bracket again. All right. What about the next one here? Domain and range. Well, let's see. Here's our most left point, and so it's a closed circle, and it's at -3, so we have a bracket at -3, and then we move our way across, and we go up, and we come back down, and this is the furthest right we go, and it's a 2, but it's an open circle, so we have a parenthesis. Okay. Now, what we want to do is we go from bottom to top. So that's our range. Well, the bottom point here is at this point, and it's a closed circle, so we're going to have a bracket, and it's at -5. Now, we can go all the way up, and we follow and follow and follow. That's our peak, and then it keeps going down. So the peak is here, and so that's at 4. Now this is included, it's part of the line, so that's a bracket as well. So don't get tricked by that 2 and say, oh, the range is from here -5 to 2. All the way up here is where it stops. Now it comes back down again, but we want to know the max part, and so that's why it goes from the -5 to the 4, including both of those endpoints. All right, so the next one here, it looks to be the most tricky of all of them, because we've got, 2 pieces to the graph, and we have to think about how the x's and the y's work, and because we're going, down here, and then we're coming up here, and then we're going down here. So the domain, if we start from the left point, now this is a closed circle here, and this is a closed circle here, and closed circle here, and closed circle here, it looks like. And so if we're going from the left point, that's a closed circle at a -6. So we're going to go from a -6, and then we move across here, and we stop at that point here, which is a -1/6. And it's a closed circle. Okay, now we union, and now we move across, and now this red line means it's not included. And so then we start here, and that's at a 1/6. So it's a closed circle, so we have 1/6. And we move across, and as that does that, we get to the point 6. And again, it's a closed circle. So we have the bracket. So that would be our domain. Now range, we're going to start here at the bottom and work our way up. So the range, well, we start here, and that's at a -6, and it's a closed circle, so -6. Then we move up, 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 and we stop at that point here. We're not ever touching the x-axis, so we stop at a -1/6. It's a closed, and so it's a bracket. Then union, now we jump up, well, now we have to jump all the way over here, and that's at 1/6, so we say, okay, well, that starts at 1/6, and it goes up, 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 up here to 6. And it's another bracket because it's a closed circle. And so this one, our domain and range is a little more complex, but again, following just the blue lines, it's pretty easy to get to where we need to be. All right, so what about the last one? Well, the last one should be pretty easy compared to the third one there. And so here the domain and our range. Well, our domain, we start here at -4, it's included. And we go all the way, and guess what? It just says keep going that way. So it's just from -4 to infinity. Okay, well, but our range? Well, it starts here, and that's the first point. So that's a -2, it's included. And then it goes up, up, up. And if you notice, it just keeps pointing up. It's going to just keep going all the way up. And so it's going to go to positive infinity as well. Okay, so when you have that arrow, that means it just continues in the same direction. And so it's going to the right positive and it's going up positive. And so that means our positive infinity is going to be the endpoint there. All right, we have something called piecewise functions as well. Now these are basically functions in which more than one formula is used to define the output over different pieces of the domain. So we might say there's, in this case, there's 3 different parts of the domain. We have the part that covers this quadratic, then we have a linear constant part here, and then we have just a normal line here part. So there's 3 different parts here. And so in situations where the rule or relationship changes as the input crosses certain boundaries, we're going to have a piecewise function. So, we have the piece here, and then it includes that point, but then the next part of the boundary, it jumps up here. It doesn't include here, it goes over here, it includes this one. Now we jump all the way back down here, and it doesn't include that, but it goes all the way up that way. And so that's going to be what we're going to be doing, is we're going to draw our own graphs, if we're going to attempt to, from what they give us. Okay, so they want us to sketch the graph of a piecewise function and then find the domains. All right, so how do we do that? So what that means is we're going to basically graph this piece, and then we're going to graph this piece. And remember, this says y equals 2x minus 1 and y equals. Now, if we wanted to, we could put that x first and say x plus 1. That makes it easier maybe. And now we can graph these because remember, slope intercept and slope intercept, that'll make things a little bit easier here. And so our intercept is a -1, and so that's going to be our first point. And it'll probably disappear as soon as I write on it. And so then we're going to go, the slope is 2, so that's going to go up to 1, 2, and then over 1. And so now what we need to do is we need to see where it's valid. And I should have done that at first. So it's going to be valid for x less than 1. So at that 1, that's actually going to be an open circle. Now I can go the other way and go down to 1, 2, and left 1, and that would be okay. And so now what I'm going to do is I'm going to attempt to draw anyway, the equation, or this line. And again, it's probably, okay, it's going to disappear. So that's a rough drawing of it. Now the next one says at 1, and which happens to be, we have to have x greater than 1. So this is actually going to be, it's going to be on this point here somewhere. And so if we plug in 1 here for x, that gives y is 2. So if we have 1, 2, we're going to have a closed circle at that point. So that's actually going to be our first point just because of how it works. And so we just had to plug in that 1 here, and 1 plus 1 is 2. And so that's the first point. And we just go up by 1, over by 1, up by 1, over by 1, up by 1. And so then we just follow that line sort of like this. And so that's our piecewise function. So it's going to be equal to this one for x less than 1. But once x is greater than or equal to 1, we have this function drawn. Okay. All right. Now what about the next one? Oh, we need the domain. Well, the domain is going to be, well, it's going to go from -infinity. And now think about this. It's not included here, but it's included here. And so the whole domain is actually just going to be from -infinity to positive infinity because that value is actually included at that point. Now, if we had had both of them be just strictly greater than and less than, then it would have had open circles, and then we would have had a discontinuity, and we would have had from negative infinity to 1, comma, parenthesis, and then union, parenthesis, 1, comma, positive infinity, and then we would have had that split. But because they're both here, we actually have the whole domain. Now, what about this one? Okay, so we have y equals x squared, and here we have y equals x plus 2. Okay, so at y equals x squared, if we less than 0, then x is 0 here, we get y is 0, and it's going to be an open circle. Okay, and then now we can plot some points to get our next points. If we plug in -1, we get a positive 1. So -1, positive 1. Remember, this is just going to be the parabola going up this direction. So if we have a -2, we'll have 4. So then we have 1, 2, 3, 4. And then if we have a -3, that's going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that would be our final point we're going to have on this graph. And so now if we try to draw it, let me see here. Not good free drawing here. And then the next one, greater than or equal to 0. So this one's going to be a closed circle. If we plug 0, we get 2. So we have a closed circle there. And this one, remember, it's just going to keep going up when we get done. And then we have a slope of 1. So then we go up 1 over 1, up 1 over 1. And so we're just going to have that line that keeps going that direction. And so here, our domain is going to go from, now we're going from negative infinity. Now remember, we have that point here included, so it's going to go all the way up to positive infinity again. Now, if it had asked to find the range, that's going to be something different on this one anyway, because here our range is going to go from negative infinity up to that point here. So our range, let's go ahead and do the range just because it's going to be different here. So it's going to go from negative infinity up to the 1, not going to include 1, union, and then we're going to have, it's going to include, and it's going to be at 2 to positive infinity, because now it's just going to keep going up and up and up and up. Now this one, basically, this is going to be our range. We're just going to go from, well, 0, but it's going to be a parenthesis, on up to, and it's just going to go on up to infinity. Now this one is included here, and the next one's included, and so on and so on. So really, we only have to worry about that side because this side is going to be included with all those points because that's included, and so on. And so that would be our range from basically the 0 to the positive infinity. All right, so here we're given the function f of x, and we need to evaluate it at 4 different points. So f of -3. Well, what we have to do is see where does -3 fall on which piece here. Well, -3 falls within this one, and so we have to plug it in here. So it's going to be -2 times -3 cubed plus 3. Well, that's -2. Here we have 3 times 3 is 9, times 3 is 27, and it's going to be negative, so -27, and then plus 3. Now we have a negative times a negative is positive, and 2 times that's going to give us 54 plus 3, and that's 57. Now what about f of a -2? Well, we're going to do the same thing. Where does that lie? Well, that lies on the first piece, so it's going to be -2 times -2 cubed, and then plus 3. Well, 2 times 2 is 4, times 2 again is going to be 8. So that's going to be -2 times -8 plus 3. That's going to give me a positive 16 plus 3, so that's going to give me 19. Okay. And what about the next one? So f of -1. Well, that equals, and here this is where it equals, and so this is going to be the case where we use this one again, and so we'll have -2 times -1 cubed plus 3. Well, negative 1 cubed is negative 1, so we have negative 1 times negative 2 is positive 2 plus 3, and so we get 5. And our final one, f of 0, well, where does it lie? Well, 0 is going to be greater than 1 because if you think about your number line, we have 0 here, here's negative 1, so it's greater than negative 1, so we're going to have it here. And so we'll have 5 times 0 minus 7, and so that's just minus 7 because 5 times 0 is 0, so we just get that negative 7. All right, so this one we have 3 parts of the piecewise, and so we want f of negative 1. Well, where does it negative 1 lie? Well, it lies in this area here, and so we just have to plug in 5 times negative 1, and that's negative 5. What about f of 0? Well, this doesn't include 0, but this one does. So when f of 0, basically we just get 3. There's nothing to do here. Anything between the 0 and 3, it's just 3. So that means it's just that horizontal line, and that's what it is. It's just 3. Well, what about 2? Well, 2 is still in that same spot, so it's also 3. And then we have f of 4, and 4, that goes into this spot here, and so it's just going to be 4 squared, and 4 times 4 is 16, and so that would be what f of 4 would be here. Okay, so with the piecewise, you have to kind of figure out which piece it belongs to as far as the input value, and then follow what it says, 5 times x, just 3, or x squared. All right, here we have the cost in dollars of making x items is given by the function c of x equals 10x plus 500. And so that's just some cost function, and we'll be seeing cost functions throughout the class. Now the fixed cost is determined when 0 items are produced. So remember, x is items, so when x is 0, it says find the fixed cost for this item. Okay, well, so we want x equals 0, so that means c of 0 is equal to what? Well, 10 times 0 plus 500. Well, 10 times 0 is 0 plus 500. So that fixed cost is $500. Now B says, what is the cost of making 25 items? Well, again, x is items, so x is equal to 25, so we want c of 25. Well, that's going to be 10 times 25 plus 500, and so 10 times 25 is 250 plus 500, so that's going to give us 750. And then a last one says, suppose the maximum cost allowed is $1,500. Okay, so what are the domain and range of the cost function? Well, this means we have to solve for what x is if that's the max cost. And so here we have c of x is equal to 1,500, and so we have to say 1,500 equals 10x plus 500. So we subtract 500. And so we get 1,000 equals 10x divided by 10. And so x is equal to 100. Okay. So here we have the point x is 100 and c of x is equal to 1,500. And so that's going to be like our max. So that's the maximum values. And remember, to get the domain and range, you need also the minimum. Well, where was the minimum at? Well, that would have been at this point here. That would have been at x equals 0. We had c of x was equal to 500. And so our domain and range, so the domain goes from 0 up to 100, and it's going to include both of those values, and that's going to be our domain. Now our range, that's going to be also including both values, so it's going to have a bracket, and it's going from the lowest, which is 500, up to the highest, which is 1,500, and then in bracket. And so that would be our domain and range. So first we had to solve for what the x was and the total maximum cost. And then once we had that, we had the max, we had the min, and then we could plug that into our domain and range, and we get our values out. And that's all I have for 1.2.